Hello friends, in this video let us learn how to avoid collision by using linear probing, which is also called as closed hashing. In the previous video we have learned about hashing, and we also learned that in hashing a situation called collision may occur. So in this video let us learn how to avoid collision by using linear probing, which is also called as closed hashing. So let us understand it using an example. So let us take this hash table of size 5, and it already has some elements in it: 10, -1, -1, 13 and 9. So let us add one more element to this hash table, 15. So the key will be 15 mod 5, which is equal to 0. That means we need to place the data 15 into index 0. But we have data 10 already present in the table at the same position. That is, this index 0, which was meant to be the place for data 15, is already occupied by data 10. And this situation is called collision. Two or more elements are pointing to the same hash index under the modulo size operation. So how can we handle this situation? If the supposed index is not free, then we can go and check for the very next index. And if it is free, we can place the data there. So see here, we have to place 15 at index 0. But it is not free, so we can go and check the next index, which is 1. And it has the value -1, which means it is available to insert the data. So we can place the data 15 at index 1. Now let us try to insert another element, 20. So the key here will be 20 mod 5, which is equal to 0. That is, we need to place the data 20 into index 0, but we have element 10 already present here. So again, there is a collision. So what do we do now? We go on and check the next index, which is 1, and it has the value 15, which means it is already occupied by element 15 and it is not free for another insertion. So again collision occurred. So what can we do now? We just follow the same process again. That is, we will check the very next index, and this will continue until we find an available index. And here the next index is 2, and here we have value -1, which means index 2 is available to insert the data. So we can place 20 in index 2. So this is how we handle collision. Here, if any collision occurs, we are linearly checking for the available index one by one. So this method is called linear probing. So in linear probing, if any collision occurs, the formula to calculate the new key value is f of x equal to x plus I mod size, where I equal to 1, 2, 3, 4, etc. So let us insert some data and understand the working principle of linear probing. First, let us create and initialize a hash table of size 5. So now all the indices are filled with value -1, which means currently all the indices are available for insertion. And we have key equal to data mod size. First, let us insert data 13. So apply it here in this equation and we will get 13 mod 5 equal to 3. That is, we have to insert 13 at index 3, and here index 3 is holding value -1, which means it is free. So insert it there. Now let us insert data 1. So again apply data 1 in this equation and we will get 1 mod 5, which is equal to 1. That is, we have to insert 1 at index 1, and here index 1 is holding value -1, which means it is available for insertion. So insert it there. Now let us insert another data, 6. So apply it in this equation and we will get 6 mod 5 equal to 1. That is, we have to insert 6 at index 1, and here index 1 is holding the value 1 and not -1, which means it is already occupied. So a collision occurred. So what do? We have to check the next index. That is, we will now use a different equation, which is key equal to data plus I mode size. And applying data 6 here, we will get 6 plus 1 mode 5, that is 7 mode 5, which is equal to 2. So we have to check index 2, and it is holding the value -1. That means it is free for insertion. So insert 6 at index 2. Now let us insert another data 11. So apply it in this equation and we will get 11 mod 5 equal to 1. That is, we have to insert data 11 at index 1 of this hash table. But when we check, index 1 is holding the value 1 and not -1, which means it is not available for insertion. So a collision occurred here. So we have to apply data plus I in this new equation and we will get 11 plus 1 mod 5, that is 12 mod 5, which is equal to 2. That is, we can try to insert 11 at index 2 of this hash table. So check index 2 and it is holding value 6, that is it is also not free for insertion. So increment I and apply data again in this equation. Now we will get 11 plus 2 mod 5, that is 13 mod 5, which is equal to 3. So check index 3 and it is also not free. So again increment I and apply data in this equation. And now we will get 11 plus 3 mod 5, that is 14 mod 5, which is equal to 4. So check index 4 and it is free. So insert 11 at index 4 and that is done. Now let us insert the data 10. So apply it in this equation and we will get 10 mod 5, which is equal to 0. That is, we have to insert 10 at index 0 and here index 0 is holding the value -1, which means it is available. That is, we have to insert 10 at index 0 and here index 0 is holding the value -1, which means it is available for insertion. So insert 10 at index 0. Now let us insert another data 15. So apply data 15 in this equation and we will get 15 mod 5, which is equal to 0. That is, we have to insert data 15 at index 0, but it is already holding the value 10 and not -1, which means it is already occupied and it is not free for insertion. So we can say that a collision occurred here. So apply data plus I in this new equation and we will get 15 plus 1 mod 5, that is 16 mod 5, which is equal to 1. Again, when we check index 1, it is not free. So again increment I and apply data in this equation and we will get 15 plus 2 mod 5, that is 17 mod 5, which is equal to 2. And we can see index 2 is also not free. So again increment I and apply data in this equation. And we got 15 plus 3 mod 5, that is 18 mod 5, which is equal to 3. Again, index 3 is not free. So again increment I and apply data in this equation. And we got 15 plus 4 mod 5, that is 19 mod 5, which is equal to 4. So check index 4 and it is also occupied. And we have applied this data in this equation with I taking all the values less than size, and we did not find a free space. So we can understand that the hash table is fully occupied now. So this is how linear probing solves the problem of collision. So today we learned about linear probing, which is one method to handle and avoid collision. And here, whenever collision occurs, we linearly check for an available index. And also, like insertion, searching and deletion are also performed linearly like this. So in the next video, we will understand how to implement hash table using linear